Welcome to The Explainer. Today we're diving into this absolutely fascinating story about how humans, history, and plants shape the very world we live in. We often think of nature as something happening out there, right? Kind of like a documentary we're just passively watching from the couch. But the truth is, the choices humans have made over thousands of years, deciding which plants to grow, trade, and transport, have triggered this massive chain reaction. And today, we're going to trace that reaction all the way from the stubborn weeds in your backyard, straight up to the global atmosphere.
Okay, let's dive into this. We all know weeds are annoying. You pull them up, and boom, they're right back. But what actually happens when a seemingly harmless garden plant decides to rewrite the rules of the global climate? I know, it sounds a bit like science fiction, but it's happening right now. We're going on a journey that scales all the way from a tiny local garden to the entire planetary atmosphere. But to really get how we got here, we've got to rewind the clock a bit.
All right, starting with Section 1, the history of moving plants, from ancient travelers to modern trade. Because humans have been lugging plants around the globe for thousands of years, it's totally tied to our cultural history, our agriculture, and even ancient conquests.
So, first up, what exactly is an archaeophyte? Basically, it's a plant species that isn't originally native to a specific region, but it was introduced way back in what we'd call ancient times. When early humans started farming, and later when the Roman Empire was expanding everywhere, they brought seeds with them, sometimes on purpose, sometimes totally by accident, stuck to animals or just blowing in the wind. Almost all Central European archaeophytes actually came from the Mediterranean and Western Asia. We're talking about plants you probably think of as completely local and natural today. Cultivated apples, pears, wheat, barley, and even those gorgeous field poppies.
And this brilliantly illustrates a really cool dividing line in botanical history. On one side, you have your archaeophytes, those ancient introductions from before the year 1492. On the other side, we have neophytes, which literally translates to new plants. The year 1492 is absolutely crucial here. With Columbus arriving in the Americas, the Columbian Exchange kicked off. Global trade, exploration, and ship traffic just exploded. And right along with it, tens of thousands of new plant species started moving across the oceans.
Moving right along to Section 2, the rule of tens, or as I like to think of it, the statistical funnel of invasion. Because in places like Germany alone, we are talking about tens of thousands of alien ornamental and crop plants introduced since 1492. But hey, before we panic, it's super important to know that not every new plant turns into a monster.
There are actually some strict mathematical odds at play here, which scientists call the tens rule. It works like a giant funnel. Out of every 1,000 species introduced to a new environment, only about 100 will actually manage to grow wild. Out of those 100, only about 10 become permanently established. And out of those 10, only one, literally just one, becomes a true invasive problem. You have to remember the term neophyte is completely neutral. Potatoes and horse chestnuts are neophytes, and we love them. The ones that become invasive are just that tiny 1 in 1,000 fraction that are just a little too good at their jobs. They use ultra-efficient reproduction and super aggressive growth to totally take over.
So the crucial point is the sheer scale of the damage this tiny fraction of plants can do. Are you ready for this? 12.5 billion euros. Yeah, billion with a B. That is the estimated minimum annual cost caused by invasive alien species in Europe alone. These few established invaders take a massive economic toll. They threaten human health, they wreck infrastructure, and they just devastate local nature.
Let's put a face to that massive bill, shall we? Section 3, local threats and ecosystem damage. Essentially, the villains in our backyards. First up is a real nasty one, the giant hogweed. This plant is a direct, literal threat to human health. Its sap contains these highly toxic ingredients that, when they mix with sunlight, cause severe, burn-like damage to your skin just from brushing against it. And beyond hurting people, it grows in these huge, dense patches that completely choke out native plants. Worse still, when its above-ground parts die off in the fall, the soil underneath is left totally bare and dangerously exposed to severe erosion.
Next up, Japanese knotweed. This thing is an absolute nightmare for infrastructure. The sheer physical power of this plant's root system, its rhizomes, is just staggering. It grows so thick and so strong that it literally explodes right through concrete. It destroys buildings, walls, roads, you name it. Plus, because those rhizomes are actually kind of brittle and break off easily in the dirt, they destabilize entire riverbanks, causing huge erosion problems along waterways.
And then we have plants that might look pretty but are total ecological saboteurs.
I'm looking at you, Himalayan balsam and Canadian goldenrod. These guys completely hijack the local food web. They grow so incredibly dense that they cast a heavy shadow, impoverishing native vegetation just by starving it of light. And it gets more insidious. Plants like the Canadian goldenrod produce pollen and nectar that have almost zero nutritional value. By crowding out native flowers and offering this botanical junk food, they are specifically endangering highly critical insects, like our wild bees.
Let's move on and see how this builds up, because the damage absolutely does not stop at the local riverbank. Section 4, the global climate twist. We are zooming out to the planetary scale now. We've seen the cracked concrete and the eroded soil, right? But recently, scientists decided to zoom out from the garden to look at the whole planet.
Which begs a pretty shocking question, actually. Do invasive species affect the global climate? Like, no way, right? Can a random weed taking over a riverbed seriously influence planetary warming?
Well, to answer that, researchers conducted a massive, first-of-its-kind global synthesis. They took 68 distinct case studies from all over the world to figure out exactly how these biological invasions are altering our planet's biogeochemical cycles. Basically, they wanted to know if invasive species were literally changing the way our ecosystems breathe. So, they tracked 3 heavy-hitting greenhouse gases: nitrous oxide, methane, and carbon dioxide. They were investigating whether these invaded ecosystems were turning into net sources, meaning they're pumping more of these bad gases into the air, or net sinks, where they're actually pulling those gases out of the atmosphere.
And the data they uncovered is highly nuanced, but really surprising. Overall, invasive alien species significantly bumped up emissions of nitrous oxide, which is a seriously potent greenhouse gas. The effects on methane were pretty much all over the place, inconclusive. But here is the major twist. Invasive species actually promoted carbon sequestration. Believe it or not, they were actively helping ecosystems store more carbon.
Now, what's really interesting about this data is exactly who is doing the carbon storing. When the scientists broke it down by taxonomic groups, a really stark contrast popped up. Invasive plants had a positive effect. They actively enhanced the ecosystem's capacity to store carbon. And this makes sense, right? Invasive plants often have longer growing seasons, bigger leaves, and faster photosynthetic rates than the native plants they kick out. But on the flip side, invasive animals, like certain insects and invertebrates, consistently showed negative effects. They were depleting the carbon content of their new ecosystems. Ultimately, the researchers concluded it isn't just the broad label of being invasive that matters, it boils down to very specific biological traits. For instance, plants that are nitrogen-fixing are the main culprits driving up those harmful nitrous oxide emissions. But paradoxically, those exact same nitrogen-fixing plants, along with woody plants, also have the strongest positive effects on carbon storage. And to make it even more complex, the local environment is a huge factor. The data showed that impacts are way more pronounced in areas with extremely high or extremely low temperatures and precipitation. It is just a wildly complex, interconnected web. Okay, we've zoomed all the way out to the atmosphere. Let's bring it back down to Earth for Section 5, how you can help. Actionable steps for your own backyard. Because intact nature equals a better quality of life, and you actually have the power to protect it. So here's your practical checklist. First, super simple. Just do not plant invasive neophytes in your garden. If you've already got them, swap them out for native plants. If you spot them creeping onto your property, yank them out as early as possible. You really want to resist the beginnings. Prevent them from forming seeds because I promise you, once those seeds are in the soil, the battle is 10 times harder. And crucially, dispose of your garden waste properly. Never ever dump it out in the open countryside. Seeds and those tiny, brittle rhizome fragments can easily hide in soil and yard waste and even in bird food. Prevention is always, always better than aftercare. Which leaves us with one final thought to ponder. From ancient Roman agriculture to Japanese knotweed busting through modern concrete to the incredibly complex balance of greenhouse gases in our atmosphere, it is all connected. So what role will your garden play in managing the future of our planetary ecosystem? The next time you go out to pull a stubborn weed, remember, you aren't just doing yard work. You are actively participating in a vast global story. Thank you so much for joining me for this explainer. Stay curious, and I'll catch you next time.